Alright, so this time we're doing problem 40 from chapter 6. And the problem says, as part of your daily workout, you lie on your back and push with your feet against the platform attached to two stiff springs arranged side by side so that they are parallel to each other. When you push the platform, you compress the springs. You do 80 joules of work when you compress the springs 0.2 meters from their uncompressed length. A, what magnitude of force must you apply to hold the platform in this position? And B, how much additional work must you do to move the platform 2.2 meters further? And what maximum force must you apply? So, we know from the problem that the work that you do is 80 joules and that the springs compress 0.2 meters. We also know that the work is going to be equal to 1/2 the spring constant times the distance squared. So this is going to be equal to, so K is going to be equal to 2 times W over X squared, which when you put the variables in, it becomes 2 times 80 divided by 0.2 squared. And when you do the math, that comes out to a spring constant of 4,000 newtons per meter. Now that's just the spring constant. But we're looking for the force for this part. So we know that the force is going to be equal to the spring constant times the distance that the spring is either compressed or stretched. So we know that our force is going to be equal to 4,000 times how much it's compressed, 0.2, and that'll give us the force, and that comes out to 800 newtons for part A. And that's the force that you have to press on the plate of the machine in order to compress it 0.2 meters. The second part of the question asks, how much additional work must you do to move the platform 0.2 meters further, and what is the maximum force you must apply? So, we'll start with finding the work. So the work is going to be equal to 1/2 K times X, the second X position squared, minus 1/2 the spring constant times the first X position squared. So we can then simplify this equation and write it as 1/2 K times x2 squared minus x1 squared. We can then substitute our values. 4,000 times 0.4 squared minus 0.2 squared. And when you solve that out, you find that the work needed to compress it further is 240 joules. This should be a 2, not a 3. My bad. We then need to find the force, the magnitude of the force as well for this part. So that's going to be the same thing. So our force is going to be equal to K times X. So the force is going to be equal to 4,000 times 0.4. So that's going to be equal to 1,600 newtons, which makes sense that it should be double that. And that's how you solve that problem.